So far, we know how to solve quadratics two different ways. One is by graphing, and we're just using a grapher. I know that you know how to graph already by hand, but to be a little more specific, we're doing it in a grapher called Desmos. The second way we know so far is factoring, where we factor and set both pieces equal to 0. And so today we're going to learn this third method called the square root method. There's still a couple more we have to learn, but this is the beginning of that process. All right, so in order to work a square root method, we have to first remember how to simplify radicals. So for instance, with the square root of 100, that would be the same number that you can multiply by itself, or a number that you can multiply by itself to get 100. So in that case, that would be 10. Now what we're going to have to consider, though, in this section is that positive 10 and negative 10 can both be answers in some cases, because positive 10 squared is obviously 100, but negative 10 squared is also 100. So that's going to run into some cases here that we're going to work on. Anytime you have a number in front of a square root, that's multiplied. So I would read this as 2 times the square root of 16. So it would be 2 times square root of 16 is 4. So that would be 2 times 4, which is 8, if we're assuming the positive answer. And I know that I'm going to have somebody in class ask, do I add or multiply? So just know that it's always you multiply by this number that's out in front. All right, so what happens when I have a number? The next one here has to do with breaking down where we're going to have a square root that comes out. So what I like to do is use, I'm sure you've used this in class before, it's like a tree, I guess, to break it down. I like to put, if you know your square roots, then you can break this down easily. For instance, I know that 100 is the largest perfect square that goes into 200. So I'm going to write this as a square root of 100. I always put my radical, oh, actually I did that backwards, I'm sorry. I always put it on the left because I know it's going to come out even. So square root of 100 times the square root of 2 is the square root of 200. So all I'm doing is breaking it down so that 100 times 2 is 200, but I have not taken a square root yet, so I have to leave the square root symbols, and that's hard for a lot of students to understand. Once you write this, and this number over here should be your perfect square. So now this can come out, square root of 100 is 10. That comes out as positive 10. There's no square root symbol needed anymore because I already found it. And then the square root of 2, that is the breakdown of the square root of 200. So that would be the final answer. All right, so now let's look at one that has to break down with a number in front also. I'm going to break down the square root of 72. Again, my perfect square goes on the left. I know that 36 is my perfect square. So it may take you a little bit of time to find those numbers, but just go down the list. The list of perfect squares would be like 1, which we don't ever break down with, but 4, 9, 16, 25, 36, all the numbers that can have perfect squares. Let's see, 49, 81, 100. I feel like I might have missed one, but anyway, you get the idea. So 36 is the largest one that goes into 72. All right, so then the square root of 36 is 6, and the square root of 2. So what I've broken down so far is that square root of 72 is the same as 6 times the square root of 2. But there was this original 3 being multiplied to the whole thing. So now I'm going to take 3 times 6, and that gives me 18 times the square root of 2. All right, so that's, again, previous knowledge you should already have in order for us to do the lesson. Now what we want to do is start solving these things, and so we want to have the solve for t, basically. We want to know what answers t can be. So what we're going to do is take the opposite of t squared, which is going to be to square root. And I think that you all know that already. What you may not remember, though, is that when you physically square root both sides, we have to assume positive and negative answers. So when your hand writes that square root, your brain has to click and say, oh wait, that's going to be a positive answer and a negative answer. And then we just break down the square root of 400. The square root of 400 is 20, because 20 times 20 is 400. So now let's talk about why we use that positive and negative. If I took this answer of positive 20 and I plugged it in for t, basically I want to know if that original equation is true. So is 20 squared equal to 400? Yes. Well, we can't ignore the fact that negative 20 squared is also 400. So we can't just assume always positive answers. Sometimes we might have negative answers. All right? So in this next equation, what's happening is we need to get this part by itself so that we can square root both sides. We can't square root both sides right now because the 19 is in the way. So what I'm going to do is add 19 to both sides, and that will leave me with 2k plus 3 squared equals 100. Now I can square root both sides. Okay, and when I do that, my squared and my square root do cancel out. Now this is still 2k plus 3 though, and then I'm going to look at this as a positive 10 and a negative 10, remember. So I actually have two equations to solve here. I'm going to come over and solve positive 10 equal to 2k plus 3 and negative 10 equal to 2k plus 3. So now when I subtract, and all that means is that I have a quadratic that's going to have two answers. So k is 7 over 2 and negative 13 over 2. Again, that means I have a quadratic that is at what, like 3.5 and negative 6.5, somewhere in there. So I just have a quadratic like this. Okay, no big deal. I still have two answers in a quadratic. Now feel free to pause and play this one. Oh, there we go again with the bells. Sorry. All right, so what you could do is try it and then play so you can see how I end up answering the question. But definitely try it first, because that's how you learn. All right, in this first question, we'll call this J. What we're going to do is get the x squared by itself. I cannot square root right now because then I'd have to work with the square root of negative 5, and I don't like that. So I'm going to just get that negative 5 out of there first. So I have x squared equals positive 100, and then we already know that when we square root both sides, our answer will be positive negative square root of 10. Okay, for the next one, I want to get that 10 out of there. So I have 2m squared. Oh, I hope nobody's colorblind to red and green like Jeff is. You'll be able to see this one. So m squared is 100. Square root both sides, and m is positive negative 10. Okay, so far so good. Now let's, and this, we'll call this one f. And what we're going to do is divide by 4. So we have x squared minus 8 is equal to 21. Now we're going to add 8 to both sides. So you have x squared equals 29. And we're going to square root both sides. So x is positive and negative. Now there are cases where we may not have a whole number. There's no perfect square number that goes into square root of 29. So in that case, for an exact answer, we're going to leave square root of 29. Now, you might see some worksheets that ask you for an approximate answer, and all you'd have to do in that case is take your calculator and work out the square root of 29, and now we can round that off to 5.39. So if for some reason we had to graph it, we would have enough information to do that. All right, now we're going to call this one H and U. Okay, so we're going to add 6 to both sides. We'll have x plus 2 squared is equal to 36. Now we can square root both sides. So x plus 2 is positive 6, and x plus 2 is also negative 6. Remember, I square rooted, so I have to assume positive and negative. So my answers are x equals 4, and let's see if I subtract 2, x equals negative 8. Okay. All right, and this one I'll add add 18 to both sides, so I have 3x plus 6 squared is 18. Square root, now I can square root both sides. I have 3x plus 6 is equal to, now I do need to break this down, so I know it's going to be positive and negative, but let's see, we need square root of 9 and square root of 2. Square root of 9 is 3, so this is actually 3 square root of 2. Alright, now careful with this, we're going to subtract 6 over to that side. So we're looking at 3x equals negative 6 plus or minus 3 square root of 2. I cannot add that because I don't have like terms. Now we're going to divide by 3. It's the first time you've seen this, but your final answer is actually going to look like this. However, we can reduce, see, make this little heart. If you can make that heart with your whole numbers and you can find something that goes into all of them, then you can reduce it. So I'm going to come back over here and see what the final answer would be. This would be negative 6 over 3 is negative 2. So this first part of the heart over here, negative 2 plus or minus 3 over 3 is 1. So it'll be 1 square root of 2. So this would be the reduced answer to the original one that we found.